Hello everyone. So last video we have discussed the basics about the machine learning. I hope everyone has learned some uh, basics of understand the basics of machine learning. So in this video we are going to discuss about unsupervised machine learning, right? So let's get started. So in this module we are going to discuss about the various unsupervised model, especially k-means and hierarchical clustering, right? So machine learning unsupervised, we have already discussed what is meant by unsupervised machine learning model. So the objective or the idea of unsupervised machine learning is to group similar things. So based on the characteristics or attributes of the incoming data, input data, right? So it will group similar items, right? Similar items. So we don't have a labeled data set, right? That is very, very important. We don't have a labeled data set, right? So the objective of any unsupervised machine learning is to group similar items, right? Similar items. So how the data is distributed within the group is called density, right? Or population, right? So unsupervised algorithms will be broadly classified into clustering, anomaly detection, density estimation, right? So clustering uh, is to group similar items into a clusters, right? Clusters. So based on the distance metric or proximity measure, it will group similar items, right? Similar items. So similar items will be grouped into one cluster. Similar items will be grouped in another different clusters. Whereas anomaly detection, so normal data look like, or normal data follows one pattern. So if your data deviates from the normal pattern, then anomaly detection will be useful to detect such kind of data, right? Or defective items. So those data are called defective items, right? Then density estimation is based on the probability function, probability distribution function or probability density function, right? So it is used in the data anomaly detection, right? So how many instances located are deviated from the pattern, right? Those are called as anomalies, right? So the density function will also be useful for data analysis and visualization process, right? So issues with unsupervised learning. So compared to supervised machine learning model, unsupervised machine learning uses raw data as the input. So building of unsupervised machine learning is harder and complex as compared to supervised machine learning tasks, because supervised machine learning models uses labeled data, right? Labeled data. So another question may be rising, right? So for example, how do we know if the clusters or anomalies detected by unsupervised machine learning models are useful or not, right? So we have to validate the results, right? We have to validate the results generated by the unsupervised machine learning models. So basically there are two types of validations or evaluations, right? External evaluation and internal evaluation. So let the expert, right? Expert in the particular domain will look at the results and validate, right? That is one kind of evaluation that is called external evaluation. Internal evaluation, you have to define an objective function on clustering, right? So my objective is to create 3 clusters, one for orange, one for banana, and one for apple, right? And you have to define the characteristics or attributes of each cluster. So based on the objective function, the clusters is being created and formulated, right? So that is called internal evaluation, right? Internal analysis. And then why do we need unsupervised machine learning models? Because most of the uh, real-time data sets, right? Real-time data sets are all of the real-time data sets are raw data sets, right? Raw data. So it is very difficult and expensive to annotate all of those data sets, right? And it's nearly impossible because if you want to annotate a speech or image, right, that are being generated rapidly at in quick phase of time, right? So it is not possible to annotate all such kind of data sets, right? So in such cases, we can make use of the clustering or unsupervised machine learning model to group similar items, right? So after grouping similar items, we can use any machine learning models or deep learning models, right? And there may be cases where we don't know how many classes are there in the data set, how many attributes are present, what are the primary important attributes, right, out of so many attributes present in the data set, right? So for such analysis also we need unsupervised machine learning models to predict the primary uh, attribute, right? We need uh, principal compound analysis or any unsupervised machine learning models, right? So if you want to get inside of any raw data, then you can make use of unsupervised machine learning model, right? That's why we need machine learning model for analysis or visualization, right? So unsupervised machine learning model types, it's basically divided into two types: parametric unsupervised machine learning model, non-parametric. As the name suggests, parametric means it follows a probability distribution, right? It follows a probability distribution based on a fixed set of parameters. So most of the machine generated data sets are follow a distribution pattern, right? Most of the machine generated data will follow a pattern, distribution pattern. So you can easily analyze all the machine generated data using parametric unsupervised machine learning models, right? So if the data set is being generated by machines or industry, right, then it will follow a distribution pattern, right? By default, it will follow a probability distribution function. So you can make use of this parametric unsupervised learning model like a Gaussian mixture model, expectation maximization algorithm to predict the sample of the class or grouping the samples. Whereas non-parametric unsupervised learning, where each data will convey something about the class or objects or clusters, right? So first you have to use a non-parametric unsupervised learning for human generated data or any naturally generated data sets will be modeled or learned using non-parametric unsupervised learning, right? So first we'll discuss about clustering. So clustering, as I said, clustering is a technique for finding similar groups, right? Similar items or similar groups in the data called clusters, right? Clusters. So the data points present in a group, one single group, will have a similarity, right? Similarity in terms of the attributes or characters, right? Whereas the two data points located in different clusters are similar, right? Are similar. So we don't have any labeled data set for clustering, right? So basically the similarity between two data points are calculated using proximity measures, right? Proximity measures. So distance metric is one of the proximity measures or basic of proximity measures. So the goal of clustering is to determine the internal grouping in the data set of unlabeled data, right? So one may ask how to group similar items, right? So that is why we have to train the model in such a way that the machine will try to understand the attributes of objects or data points so that it will group similar items, right? Similar items. So based on the raw data set which is being given to the machine, right, it will apply any one of the similarity measure, right, in such a way that if two data points are similar, then the similarity measure. For example, xi, xk are two data points present in the same group, right? Sorry, xi and xk are two data points. So if they are similar, then the similarity measure value should be large, right? The similarity value should be large if they are similar, whereas the dissimilarity measure value d of xi comma xk should be small if xi and xk are similar, right? So if they are similar, the similarity value should be large. If they are dissimilar, the dissimilarity value should be small, right? So again, remember, a good proximity measure is application dependent, right? Application dependent. So you should be very careful while selecting the similarity measure for your clustering technique, right? Clustering technique. So clustering algorithms, there are again various types of clustering algorithms are there, right? Exclusive clustering, overlapping clustering, hierarchical clustering, probabilistic clustering, right? So we are going to talk about k-means and hierarchical clustering, right? So those are very familiar, right? So k-means clustering. So here, so before getting to that k-means clustering, exclusive clustering. So the data point should be exclusively present in only one cluster, right? That's why it is called as exclusive clustering, right? So the data point should be present only at one cluster, right? So data point cannot be present at more than one cluster. That is exclusive clustering. Overlapping clustering. So data points can be present in more than one cluster. So that the data points may overlap, right? So that's why it is named as overlapping clustering. Hierarchical clustering. So if you have n number of data points, each n number of data points will be considered as clusters at initial point, right? Initial point. Then one by one, similar points will be clubbed into a cluster. So until the final cluster is reached. Probabilistic clustering, it will follow a probabilistic pattern, right? It will follow a probabilistic pattern. So k-means clustering, hierarchical clustering, it's a kind of overlapping clustering, right? Or you can say probabilistic clustering. So k-means is one of the simplest unsupervised machine learning model, right? So it will group similar items based on the distance matrix, right? Distance matrix. So here the k denotes the centroids, right? K centroids will be selected for each cluster, right? So the aim of this k-means algorithm is to minimize the objective function, right? Minimize the objective function, or in other words, to reduce the error function, right? Error function. So the algorithm is basically follow these steps, right? For example, if you have n number of data points to be clustered, right? To be clustered, you have to decide the k value. For example, if you want to construct 2 clusters or 3 clusters, so based on, you have to choose the k value, right? Then you have to select the cluster center, right? So for example, look at the diagram. I have selected 2 as the cluster number of clusters, right? Then you have to select a cluster head or cluster center, all right? So the cluster center should be selected in such a way that the distance between the cluster center and the other points should be minimal. So the objective function is to reduce the similarity measure, right? Similarity measure. So this is my first cluster and this is the second cluster, right? So if you select, this is the cluster center for the second cluster, the similarity measure will be large. So in the next iteration, the cluster center will be changed so that the similarity measure should be minimal between the cluster center and the other points located on the cluster. So these 2 points are very close to the cluster 1. So in the later iterations, so the 2 points are removed from cluster 2 and joined to cluster 1. So the cluster formation will keep on moving until the final cluster is arrived, or if if for more than two or three iterations, if the cluster points and cluster center is not changing, then that is the final cluster generated by k-means clustering, right? So k-means clustering, the similarity measure can be calculated using Euclidean distance, right? Euclidean distance or Euclidean space, right? So the mathematical formula is a m, that is mean distance, is equal to 1 by c sum of xi. So here the c denotes the number of data points in cluster Cj, right? And the sum of data points to centroid mean is computed with this formula, right? So as I said, the similarity measure should be large if they are similar, right? Similarity measure should be, or similarity value should be large if their two data points are similar, right? So here is the implementation of k-means algorithm. I have randomly given some data points for two variables x and y. So I have imported matplotlib library from Python, right? And I have generated the scatter plot of x and y, right? So where you can see the scatter plot of x and y. So from this scatter plot, you can calculate how many clusters you want to generate for these two data points, right? So basically, if you don't know how to start with k-means implementation, you can use a method called elbow method, right? Elbow method is used to calculate the number of clusters you have to start with, right? You can start with, so k-means clustering, see here the elbow method. If you don't know how many clusters you have to start with, you can use the elbow method. So elbow method, so where the change is gradual, right? See, after the number 2, the change is very gradual, but between 2 and 1, there is a rapid change. So after 2, the change is very gradual, right? Very slowly changing. So the optimal number of cluster is 2. So you can select the value as 2, right? So you can select k is equal to 2, and we can select clusters, number of clusters is equal to 2. It will automatically fit the data into 2 clusters, right? 2 clusters. You can also give labels to the clusters, 2 clusters. The weakness of k-means clustering is, right, the way to initialize the k value is not known, right? It's not known, or you have to select the k value, randomly select the k value, right? Or you have to use the elbow method, right? Elbow method. So if a particular data point is empty, right? If a particular data point is empty, it cannot be updated to any of the clusters, right? So generally the data point which is empty will be ignored, right? Ignored. So there is no optimal way to select the k value. That is the only weakness of k-means clustering, right? Next one is the hierarchical clustering. So hierarchical clustering, the objective is to find the similarity in such a way that you have to form a hierarchical tree, right? You are going to form a hierarchical tree. For example, you have a various types of cars, models of cars, right? So all the cars can be initially considered as one group, right? One group. So under from the one group, Honda brand can be grouped into another subgroup, right? Similarly, the Hyundai, Tata, Maruti. So you can divide the entire group of cars into number of leaf nodes, right? Number of leaf nodes. Further, under Honda category, under Honda model, you have various models of cars, right? Honda Amaze, Honda City, right? Similarly, Tata Nexon, Tata Punch. So you can, like this, you can form a hierarchical clusters, right? So where this hierarchical tree resembles a tree structure, right? This hierarchical tree is called as dendrogram, right? This hierarchical tree structure is called as dendrogram, right? So you have to start with n number of data points. So if you have n number of data items to be clustered, so each n items will be considered as n clusters first. At first step, each n data points will be considered as n clusters, right? The next step, you have to find the closest pair of clusters, right? You have to find the most closest pair of clusters and merge them into a single cluster, right? So likewise, the process will iterate, right? Iterate. Then you have to find the distance between the new cluster and each of the old clusters, right? So this process will iterate until all the items are grouped into one cluster, right? So under root node, you can have leaf node, right? So the advantages of hierarchical clustering, it is robust, right? It will provide a detailed information, right? Flexibility, easy to apply and interpret, scalability, right? Whereas the disadvantage is computational complexity. If you have large volumes of data points in your cluster, then it will take time, right? The computational time is more, the model is complex, right? And arbitrary decisions is not, it will take some arbitrary decisions based on some assumptions, and it is also sensitive to noise, right? Then optimal results are not guaranteed in hierarchical clustering. See, hierarchical clustering, there are two approaches. One is agglomerative, divisive. So agglomerative, see, you can see it follows the bottom-up approach. Bottom-up approach. So where it will follow from a leaf node to root node. Divisive approach, it follows a top-down approach. So all the data point starts in this from root node to leaf node, right? So we'll see the implementation of hierarchical clustering. See, we have multiple data points, right? So each data point will be joined, so considered as a n number of clusters at first, right? So the similar items will be formed into one cluster. So point number 1 and 2 will be joined to form a cluster 1. Similarly, 5 and 6 and 3 and 4 will be joined to form a 3 clusters. Then you can also group these 3 together to form the root node. So this is how the hierarchical clustering will be implemented, right? So agglomerative clustering is a bottom-up approach, right? Bottom-up approach, whereas a divisive approach follows top-down approach, right? Top-down approach. See, here is an example for agglomerative hierarchical clustering. This is step 1. It will follow bottom-up approach. So it starts clustering by treating the individual data points as a single cluster, right? Single cluster, then it is merged continuously until it reaches the large one, right? Large one. You have to calculate the distance matrix, right? Distance matrix. The process will be iterated. See, based on the distance matrix, if they are similar, it will be grouped into one cluster. So here, for example, 2 and 3 are similar, right? It will be grouped to one cluster. Similarly, 4 and 5 are clubbed in one, and the next first step, right? Then 2, 3, 4, 5, 6, 4, 5 and 6 are clubbed in the next step, right? In the next step 3, 2, 3, 4, 5 and 6 are clubbed, right? At last, all the data points are clubbed together. So this is the bottom-up approach or agglomerative hierarchical clustering. So here is the implementation part for hierarchy clustering. I have imported the packages pandas and numpy, right? And I have given the data path, right? The panda will read the file, right? I have to implement the agglomerative clustering from the Python package sklearn package, right? I have given the cluster number 3 and metric Euclidean distance and linkage function is word, right? And the model will predict the structure, right? Structure, see, this is the dendrogram chart generated by the model, right? Dendrogram chart. From the dendrogram chart, how do you find the optimal number of clusters? So to find the optimal number of clusters, you have to draw a horizontal line where there is no overlap in the vertical lines. See, here I am drawing the horizontal line where there is no overlapping. So if you draw a line here, there will be overlap, right? There will be overlap here and also here. So the optimal number of clusters are the number of vertical lines below the horizontal line. So that is 3, right? 3 is the optimal number of clusters. So the next module we will talk about NLP and text mining models. So if you have any questions on unsupervised machine learning model, you can put it in the comment box. Thank you for all, right? Thank you.